Good morning, dear students. I am Dr. Srinivas Bathini, Professor of Chemistry in St. Peter Engineering College, an autonomous institution. Today, I am going to explain LCAO. What is the topic? Today, I am going to discuss the LCAO. It's a very important topic. LCAO. So before going to discuss this topic, what I did explain? What did I explain in the last video? What are the topics we discussed? What did I explain in the last video? They are atomic orbitals, molecular orbitals, molecular orbitals, sigma bond, pi bonding molecular orbitals, sigma bond molecular orbitals, anti-bonding molecular orbitals, bonding molecular orbitals. No? So these are the topics, I think. Okay? Now we have to discuss this topic. So what is LCAO? What is LCAO? Can anybody know of this one? LCAO. It's an intermediate topic. LCA is a linear combination of atomic orbitals. What is that? Linear combination of atomic orbitals. So this is the topic they are going to discuss. Linear combination of atomic orbitals. According to quantum mechanics, we know the quantum mechanics in the 10th class intermediate. We studied already. The quantum mechanics, the exact position and momentum of an electron cannot be determined accurately. Isn't it? What is that? The exact position. Position and momentum cannot be determined accurately. This is whose principle, you know? Whose principle? Heisenberg uncertainty principle. Whose principle this one? Exactly position and momentum cannot be determined. This is the principle. Heisenberg uncertainty principle. So to understand the structure of an atom structure, to understand the structure of an atom or chemical combination, we have mechanics used. So to understand the structure of an atom or chemical combination, wave mechanics is used. What is that? Wave mechanics. You know that wave. This is the wave. Schrodinger equation, you know the wave equation. Crest and trough. The wave mechanics. According to wave mechanics, atomic orbitals can be represented by wave function. The wave function is the psi. What is that? According to wave mechanics, atomic orbitals can be represented by wave function. It is denoted by the psi. This is the wave function, that is psi. If, example, if two atoms are considered, that is psi A and psi B. For example, psi A and psi B. We consider two atoms, A and B atoms. What is that? A and B atoms combined. So what are the wave functions of the atom? Psi A atom, psi B atom. According to wave mechanics, atomic orbitals can be represented by the wave functions psi A and psi B. Mean two atoms A and B. When these atoms approach each other, these wave functions approach psi A and psi B. Approach. Here, what? When these two atoms approach the electron cloud of these two atoms, undergo overlap and produce a molecular orbital psi AB. It can be represented by the linear combination of psi A and psi B. So, like this. If two atoms A and B, atom A, atom B, wave functions are psi A, atom A's wave function, atom B wave function. These two atoms approaches each other. What? Electron cloud. Overlap electron cloud. This is the electron cloud. Totally electron cloud. The psi A atom and psi B atom approaches each other to form the which molecule? Psi AB. This is the molecule. Psi A and psi B is the molecule. When two atoms, that is wave function of psi A, the psi wave function means electron cloud of A and electron cloud of B approach each other to form the psi AB. This is called what? Molecule. This is called the molecule. So here that what happened? Psi A and psi B. So how can we write this one? It is a linear combination. Mean the linear combination of A and linear combination of B. Of what? Psi A and B. Mean psi AB molecule. Okay? So now can we see the one example? What example we have to take? The simple most example is the hydrogen atom. Example is what? Hydrogen. So here the two atoms are there. Psi A and psi B. So what is the diagram? We can see this one. Psi A and psi A. So that energy level we have to see that. In hydrogen atom, how many electrons are there? Only one electron. mean that is the 1s. One hydrogen is having the 1s, and another hydrogen is having the, this is also 1s. So 1s and 1s. Here, this is the energy level diagram. Energy, okay. This is the 1s electron. This one is the 1s electron. Only one electron is there. That is 1s. Okay. Now, this is one more. Here, one electron means 1s. So two 1s mean two hydrogen. Hydrogen means two atoms combined to form hydrogen plus hydrogen to form the H2. How it is formed? According to linear combination of atomic orbital. Linear combination. See, here the formation takes place. How it is formed? One is the plus, we know that plus and minus. So these two atoms, one is a sigma s, one is and sigma star, one is sigma star, one is. Mean here the 1s is called what? Atomic orbitals. Atomic orbitals. Orbital. Here one is also atomic orbital. But here, what is this? This is the H. Okay? This is the H. 1H, 1H. Atomic orbitals. To form the what? Molecular orbitals. That is H2. Molecular orbitals. Psi A atom, psi B atom. Psi A B mean H2. Psi A. So psi A wave function. Psi mean wave function of A atom, wave function of B atom. 2H combined to form the H2 molecule. That is molecular orbitals. Understand? The molecular orbital mean that is the AB. That is the molecular orbital. Understand? This is the very good example. You draw it. Please draw it, this one. Okay. Now, so here, so what is sigma star s? Sigma star 1s, sigma 1s. So what is this? Here, sigma 1s is the bonding atomic orbital, molecular orbital, and sigma star is the anti-bonding molecular orbital. So how can you represent that one? How can you represent? So can you look here? What is the example I have taken? Just hydrogen molecule. Like that, many molecules. We have to discuss the common psi A and psi B. A is the hydrogen or chlorine or whatever may be atoms. B is also different. So let's look at the A and B, two atoms. Okay. So two atoms in psi molecular orbital. What is the psi molecular orbital? Psi molecular orbital means AB. This is the molecular orbital. Psi AB is the molecular orbital. Equal to psi A plus or minus. What is plus or minus? Psi B. Okay? Psi A and psi B. The two molecular orbitals. What are that? Two molecular orbitals. What are that? Psi A plus psi B. One is a psi A minus psi B. So now just before bonding electron, anti-bonding electron. The bonding is the sigma. Sigma is equal to what? Psi A plus psi B. This is the sigma bonding atomic orbitals. And anti-bonding atomic orbitals, anti-bonding molecular orbital is the psi A minus psi B. This one, that indication. Mean in the diagram, psi bonding and sigma bonding and sigma star bonding. The sigma star is the psi A minus psi B, that is anti-bonding. Here the anti-bonding. And here bonding. Bonding atomic orbitals. So now for this we have one principle is there. What is that? How can you? The psi AB equal to one equation we will write. Psi AB equal to, psi AB means molecular orbital, equal to N into C1. N into C1 psi A plus C2 psi B. Psi B. So what is C1 and what is N? We know the psi A and psi B. Sigma star and sigma star. But now the new two things came. So what are that? N is equal to what? N equal to what? And C is equal to what? N is equal to normalizing constant. What is that? Normalizing constant. Normalizing constant, which is used to find the probability of finding the electron in the space unity. What is that? This is the probability of finding an electron. Yeah, finding an electron in where? In space unit. Electron in the space unity. What is that? Once again listen. The N is the normalizing constant, which is used to find the probability of finding an electron in the space. Space is unity. C1 and C2 is equal to what? They are also constant, used to give minimum energy for psi A and psi B. C1 and C2, minimum energy to give psi A and psi B. Minimum energy. Mean that is the molecule. Psi AB molecule. We can write the psi AB molecule. So that is about the C and N. C and N. So the probability of finding an electron, for example, the probability of finding an electron in density and volume, the probability of finding an electron in volume of space, the probability of finding an electron in volume of space, dV, d is the density and v is the volume, is psi square dV. If the probability of finding an electron dV means density and volume, the probability of finding electron in volume of space is psi square dV. Psi square dV. Psi is the wave function. Psi square dV. These force the probability density for the combination of two atoms is related to wave function squared. That is psi square. What is, once again, listen this one. The probability of finding an electron in volume space dV is psi square dV. These force the probability density for the combination of two atoms is related to wave function squared. Psi A and psi B. That related to square. Psi square. Now can you write the equation? Psi square AB. What is that? Psi square AB. Psi square AB is equal to C square 1. C square 1. Psi square A. This one. Psi square AB mean molecular orbitals. C square 1 and psi square A plus C square 2 psi square B. Psi square B plus A plus B whole square. A square plus B square plus 2AB. You know the 7th class. A plus B whole square. A square, this one. B square, this one. And 2AB mean plus 2 C1 C2. C1 C2 psi A psi B. Psi A psi B. That is 2AB. Okay? So this is about the one equation. So you must remember this equation. But what about the C square psi? What is meant by C square psi? Just before I told you, what is that? It's the probability of finding an electron on atom A. This one is the probability of C1 square psi square is the probability of finding an electron in C square. C1 square is the probability of finding an electron on atom A. Probability of finding an electron in atom A. And this one be the probability of finding an electron on atom B. The probability of finding an electron on atom A. The probability of finding an electron on atom B. Okay. So this is about the equation. Okay. Now for this we have some rules are framed. Some rules. Why the rules are framed? How can we decide? How can we decide and which atomic orbitals may combine to form molecular orbitals? Some rules should follow. So how can we decide which atom is which atom? Which atom orbitals may combine to form the molecular orbitals? So some rules are there. So we must follow. So that is also called as what? Rules for LCAO. What do we say? Rules for LCAO. Rules of LCAO or rules for LCA. Okay, rules for LCAO. What are the rules? The first rule is what? Only 3 rules are there. Don't worry, you have to remember the 3 rules. So here that the 3 rules, the first rule is what? The atomic orbital must possess roughly the same energy, particularly while considering the overlap of 2 different types of atoms. Same energy level, 1s and 1s mean hydrogen. Same energy levels, just before we have seen 1s and 1s, same energy level, 1 hydrogen, only 1. So the atomic orbitals must possess roughly the same energy, particularly while considering the overlap. Considering the overlap of 2 different types of atoms. 2 different types of atoms. Okay, that is the first rule. And the second rule, sir, only hydrogen is the same atom, different atom. We can take any atom, the energy level should be nitrogen, oxygen, hydrogen, chlorine, but the 1s level. or 2s labor, like that, or 2p same, 2p, like that. So that is the energy levels. Okay, and so once again listen, what is that first rule? The atomic orbitals must possess roughly the same energy, particularly while considering the overlap of two different atoms. And the second rule is what? The orbitals must overlap one another as much as possible. As much as very close. They must be close enough for effective overlap. For example, here the two atoms are there, for example. So these are the two atoms. So maximum overlap takes place. This is the electron cloud. This is the electron cloud. So maximum for here, maximum. Little distance. So maximum overlap. This is the maximum overlap. So the overlap is the maximum. This one we can see. This area is the maximum area. Maximum. Here the blue color is there. Here the yellow color is there. So, but around this is the maximum overlapping. So, overlap, maximum overlap. The second rule is what? The orbitals must overlap one another as much as possible. They must be close enough for effective overlap. What is that? Effective overlap. That is the second rule. And finally, the last rule is what? We know that last rule is to produce bonding and anti-bonding molecular orbitals. What is that? Bonding, sigma. Anti-bonding, sigma star. The bond to produce bonding and anti-bonding molecular orbitals. The symmetry of two atomic orbitals must remain uncharged, or both atomic orbitals charge symmetry in an identical manner. When rotated about the internuclear axis. The charge should be that both atomic orbital charge. This is the minus or plus, the atomic orbital charge. Symmetry in an identical manner. The symmetry should be in an identical manner when rotated about the internuclear axis. Rotation takes place, so symmetry should be the same. Symmetry should be the same. This is the third rule. Okay? So, what we have discussed today? LCAO. What is that? Linear combination of atomic orbitals. Okay, first we have seen that Heisenberg uncertainty principle, in that no two electrons. And then what? Some examples I have given. Which example? Hydrogen. The 1s and 1s. Psi A and psi B. Psi is the what? According to wave function, mean wave mechanics. Actually quantum mechanics. From quantum mechanics to wave mechanics. Psi is the wave function. Two atoms we have taken, two orbitals, atom A and atom B. So both are combined to form the psi A and psi B. That is the molecular orbitals of psi A and psi B. We have taken one example, hydrogen atom. Okay, to 1s level, say. And finally, that two equation, that psi square, c square psi, c1, c square psi 1, c square 1, psi square a plus c square psi and c2, like the 2 plus 2a, 2 c1 c2 psi ap. That is the equation. Okay? And finally, rules. What are the rules? We have seen equal energy. First rule. There must be overlap another as much as possible. Energy level is the must be same. And maximum overlap. Second rule. Just two words we are in. Energy is same. You have to play different way, but you have to remember the keywords. Energy same of two different. And maximum overlap. The third one is the symmetry should be same. Identical manner. Symmetry, identical manner. Energy, overlap, and symmetry. These two words these three words, three rules. Okay? This is about the LCAO, linear combination of atomic orbitals. It is very, very important for definite question. Okay? Thank you. Bye.